last video, we have seen the different types of data sets we have, right? And we have also seen one of the examples that was related to relational records. So we have a kind of an Excel kind of a data wherein we will use that data for creating our models. Okay. So in today's video, we are going to talk about first algorithm that we are going to see today. So that is decision tree. So when we talk about machine learning, right? So machine learning has supervised learning, unsupervised learning, reinforcement learning as well, right? So in supervised learning, we talk about classification, right, and regression. So today we'll talk about the classification, and the first algorithm in that classification is decision tree learning. So decision tree learning is very simple algorithm, and it's so intuitive that you can easily explain to people that what you have built up. The model looks like very simple, so that you can even read that and understand what's going under the net. Okay. So let's start. Let us try to understand that what is decision tree learning algorithm, what are certain applications of it, and let us try to build the decision tree algorithm. Okay. Okay. So what is the task? So the task is that given us collection of examples, that is x and f of x. Okay. Now collection of examples means, let's say we have 10 records. Okay. Let's, for example, we have just taken up 10 records. Now these 10 records are nothing but examples for us. Okay, so you can see over here that we have, let's say, 10 records. So these are nothing but the examples that we are going to use for training our model. Okay, and we have f of x. Now f of x is nothing but the output kind of a column. So here the output kind of a column is cheat. So we are going to take an example of ITR filing only, right? So by filing the ITR based on certain attributes or certain columns, we are going to decide whether the person is cheating or not. Okay, so collection, so let's revise it again. Given is collection of examples, that is x and f of x, whereas x is nothing but features, f of x is nothing but the label or the class. Okay, and what is the return we are going to get? We are going to get a function or a hypothesis that approximates the f, where h is a decision tree. Now in return you are going to get a decision tree wherein based on your certain features you are going to get the output. Okay, so simple, right? And when we talk about the input and output, right, so input is nothing but a set of attributes and output is a decision tree. So this is a kind of a decision tree. On the right side you can see that this is a decision tree that we are going to get as an output. Okay, what are certain applications of it? So first application is like predicting tumor cells as benign or malignant, right? So this is like a classification task, a binary classification, where we're going to classify the tumor cells. Okay. Then again, classifying credit card transactions as legitimate or fraud. Okay. So we are going to take some samples wherein I will have some records that are showing as legitimate, some records as fraudulent. Based on that, we are going to build up a decision tree, and after that decision tree, we're going to identify the new records as either legitimate or fraudulent. Okay, this is so simple. Then categorizing the news story as finance, weather, entertainment, sports. So decision tree is almost used everywhere because it's so simple and it's so intuitive to understand. Okay, so in the last example, just categorize the news story as finance, weather. So we can say that this is nothing but a multi-class classification because there are more than one classes over here. Okay, now let us try to understand like what is a decision tree, how actually we can understand what is going on from the decision tree. Okay, so on the right side you can see the decision tree, right? So on the top we have the refund attribute. So whenever refund equals to yes, then we can say that person is not cheating. So even you can see that this tree has been built from this data, right? So in this data you can see the refund attribute. So wherever there is yes, the output column is no. Okay, so we don't need to further split it because for every refund yes, we are always going to predict that person is not cheating. But if the refund is no, then just look at the table where you can see the refund no and cheat equals to no and yes. That means for refund equals to no, we are having the output as no and as well as yes. Now, since we have two outputs, we're not going to get it correct, right? So we need singular attribute. For example, refund equals to yes, it gives us the no only. Every time we get refund equals to yes, there is one output column label. There is one label attached to it. Okay. But when refund equals to no, then there are two labels attached to it. And now what is called, whenever there is one label, then it is called as a P1 node. And whenever there is label, there are more than one labels attached to the particular attribute, then we can say that it is impure node. Okay. So this is the way we are going to build up a decision tree, and you can even see this decision tree and understand it from. You can just pass the decision. You can understand whether the person is cheating or not, right? But how the refund attributes is at the top. After that, why we have chosen the malicious status. This is a point of a discussion, and we're going to discuss that. Okay. So we're going to see that in the next video. For this video, that's all. Thank you.